Hi, hello everyone. Welcome back to Data Mining Video Lecture Series. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of Data Mining Video Lecture Series, in this lecture, we are going to discuss one very important concept in data mining, that is association rule mining. So today I am going to give an introduction to this association rule mining. So here in this lecture, we are going to discuss mainly. So first we need to understand what is a transactional database. So then what is association rule mining. In this, again, we need to understand what do you mean by a frequent item set and what is a priori download property, or some other basic concepts will be discussed in this lecture. So without wasting much time, let us move. So association rule mining. So I just would like to start from the beginning. Before I would like to give what do you mean by this association rule mining. Later we'll go in detail. So association rule, an association rule would be like, suppose if X then Y. So that is, if a customer purchases product X, and what is the probability to purchase the product Y also. Okay, so if a customer purchases X items, and what is the probability of purchasing the Y item. So we have to find out this kind of rules from the transactional database, so that we could improve the sales by giving some discounts or making the combos, arranging the items in supermarkets, shelves side by side, etc. We will discuss in detail what are the main applications, etc. in next lecture. But here I would like to give very basic concepts, so that the rest of the concept would be easily understood. So here this association rule mining is a two-step process, and this is a two-step process. This is a two-step process. So first step includes the frequent item set generation. Frequent item set generation. Second, association rules, generating frequent item set generation and then derive the association rules. Association rules. So this is very easy. It's a direct process. But the first step is costly process. That is, we have to generate the frequent item sets. So that's why we have to understand why it is a costly process. So let us take the first one, the frequent item set generation. So before, let us see what is a transactional database. So most of the time, when we visit supermarket or shopping malls or any online e-commerce websites, we could purchase the set of items, right? Item or set of items. Here, what do you mean by item, and how the transactions, whatever the purchases done by customers, are represented in this data mining, and how we'll find these frequent item sets. So for example, let us say in a supermarket, there are some 5 items. This is only for understanding, but in the real world, a supermarket would have more number of items. So supermarket for 5 items. So let us say the 5 customers visited the supermarket. So 1, 2, 3, 4 and 5 are the customer IDs. Let us say this is a customer ID, CID or a transaction ID. We would also give the name called as a transaction ID. So now there are 5 items in this supermarket. So A, B, C, D and E. This is for simplification. So, and these 5 customers purchased the items, not all the common items. So let us say the items purchased, I just would represent this in the form of like this. The first customer, that is a transaction ID 1, they purchased the items like A, B and E. And similarly, customer 2 purchased A, C, D. And similarly, third customer purchased B, C. And fourth customer purchased B, C, D. And fifth customer purchased almost all the items. Okay, so this, but here actually in the real world database, this information would be recorded. Here the items like item code or item name or some other item identity will be given for each item. So that will be there in this top. And here this is a transaction that is done by a particular customer. So each transaction would include the items and also the quantity of each item and the unit price and the total price, discount, etc. Everything would be stored in this transactional database. So similarly, second customer, third customer, like this. So this is the way when we done like a shopping, or when we purchase a set of items or products, a supermarket, a shopping mall, or any other online e-commerce website, and when we make the payment, and that would be recorded as a transaction. Okay, so there are 5 transactions happen. So these are the items the customers purchased by. So in this case, to find out the frequent item sets, what do you mean by the frequent item set? That need to be understood. Frequent item set. So item set, that means items which are occurred frequently. Okay, frequently, or items those are brought by the customers frequently, a set of items frequently purchased together. But there will be some threshold, like let us say threshold or minimum support, or there are different names, we'll discuss in detail. So threshold is like 2. That means the frequency of any item is greater than or equal to 2, then we could treat that item as a frequent item sets, because we are interested to find out the items which are appeared more than 2 or more number of times in a transactional database. So that is depends on the database and depends on the business, etc. This would be decided by the domain experts. This cannot be like, there is no particular rule or a formula to identify this threshold value. So this is done by the domain experts. They will also do the trial and error methods. So the items which are appeared in a transaction, this is a transactional database, appeared more than 2 or more number of times or in 2 or more number of transactions, then that item set is called as a frequent item set. So here again you will get a doubt, what do you mean by item set? Item set. So item set means it could be empty or it could be a single item, let us say A or AB. This is one item set and this is some ABC. This is also another item set. So item set means the set of items. It could be empty, 1 or 2 or 3 or n number of items. Right? So like suppose if you take A, so how many times this item set appeared in the transactional database? So here this is an item. This is appeared in 4 transactions. That is the frequency. It is appeared in 4 transactions. Similarly, item B appeared in 4 and C also appeared in 4. D appeared in 2 transactions and E appeared in 1 transaction. So we are interested to find out the items which are appeared more than 2 times, or more than 2 transactions, or more than 3 transactions, more than 10 transactions, or we could also express in terms of percentage also. Like suppose there are, because in the real world there will be many number of billions or millions of transactions will be there. So in that case we cannot just take this small number. So there we will take, like suppose we are interested to know about this 10% of transactions, items which are appeared at least 10% of transactions. So that is the way we'll identify this frequent item sets. So what do you mean by the frequent item set? That means the item set which is appeared more than the specified threshold value. Okay, like suppose the threshold equal to 2. So the item set, the frequency of an item set which is greater than or equal to or greater than the threshold value, and that is called as a frequent item set. So I hope this item set is also clear. It could be a set of items, single item, 2 items or 3 items, etc. So here now this transaction, how we apply this, but we, as just now I said in the beginning, this frequent item set generation process is a very costly process. So we need to understand why it is a costly process. Because, so let us take the same transactional database. So I may not replicate the same. I'll take the similar kind of a transactional database. So here the transaction ID, item A, item B, item C, etc. So in this transactional database, the transactional database in the real world, that will be represented based as per their norms, like the product IDs, product description, price, total price, quantity, etc. But if you want to apply this frequent item set mining or to find out the association rules, so that the database need to be converted into the binary format. So what do you mean by the binary format? Like suppose these are the transaction IDs. So binary format means like it will be represented, the entire database would be represented in the form of every purchase of a particular item would be represented in the form of zeros and ones. Okay, so what does it mean? So here 0 means this particular customer so did not purchase the item A. 1 means customer 1 purchased the item B. Okay, so we are only interested to know the frequency. We are not going to consider the quantity. How many? What is the quantity of item A? What is the quantity of item B? What is the quantity of item C? So we are only interested whether a customer purchased an item or not. If it is purchased, then that would be represented in the form of 1. If not, then that is 0. So this is the way the transactional database would be converted into the binary database. That is because this is one kind of a data transformation, so that we could apply this frequent item set mining to find out the frequent item sets, and then we'll derive the association rules. So now let us say there are 3 items in this transactional database, or if you want, let us take one simple example, right? So this is an example which I obtained from the internet. So this is a transactional database, like transaction IDs, that is the transaction done by a customer. Each transaction has items like A, B, D, AC, ABC, AD. So here, in this frequent association rule mining, the first step is generating the frequent item sets. So generating the frequent item sets. So to generate the frequent item sets, because I already gave the definition what is a frequent item set and what is also an item set. So here you can see here, these are all the item sets like A, B, and this is a null item set. A, B, A, C, A, D, B, C, B, D, etc. These are all the item sets. So, but here we are interested to know about the frequent item sets. So, because then we could derive the association rules in the second step. So, how this as I said just before, this information, this is represented in the form of a binary format. So then we'll get the frequency of each item. Okay, like suppose this would be represented as 1, 2, 3, 4. So item A, B, C, D. There are 4 items. So first transaction 1, there are 3 items A, B, D. A, B, D, and this would be 0 because customer 1 did not purchase item C. So similarly, the rest of the information would be represented in the form of a binary. So now let us try to understand why it is a costly or a challenging process of finding or generating the frequent item sets. So here we'll start, like suppose if there are 4 items, so 2 to the power of 4 and including the null set, there will be 2 to the power of 4 number of item sets, right? These are the 2 to the power of 4 number of item sets are possible if there are 4 items in a database. Okay, so similarly, if suppose there are 100 items, that is in the real world, there will be 100 or more than 100 also. So then the 2 to the power of 100, that would be a big number. Okay, so those many item sets, like suppose single item sets A, B, C, D, and then 2 length item sets A, B, A, C, A, D, like this, and 3 length item sets and 4 length item sets. So like this, if there are 4 items in a database, the transactional database, so then 2 to the power of 4, if we exclude this, then the 2 to the power of 4 minus 1 number of item sets will be there. So similarly, like suppose if it is, if there are 100 number of items, then 2 to the power of 100, that will be a big number. So from this number, we have to find out the frequent item sets. That means the item sets which are appeared are the item sets whose frequency is greater than or equal to the specified minimum support or the threshold. So to find out that, first the thing is we have to generate all these item sets. Like suppose 100 items, we have to generate this 2 to the power of 100 number of items. If there are 4 items, then we have to generate 8. So 15, and including, like let us say 15 items need to be generated. But this among these 15, we don't know which are the frequent item sets. So to know the frequency, or to identify the frequency, and also to know whether that item set is a frequent or not, and we have to scan the database, and we have to find out how many times that particular item or an item set is appeared in a transactional database. So in this case, like suppose the first, so in this case, like let us say, like, so these are the 5, 6, 11, 11, 4, 15, including the null 16. So let us say there are 15 items need to be generated and checked for the frequency. Okay, 15 items. So here in this process, you can see here, like let us say the minimum support threshold is 2. That means a frequency item set means that frequency should be greater than or equal to 2. So if you could observe the frequency of the item sets in this diagram, and this is a 4, 2, 2, these are the frequent item sets, 2, 2, 2 here, and the rest of the remaining all item sets, the frequency is less than 2. So these are infrequent. So now if you could generate this 15 items, and if you check their frequency, and then to find out the frequent item sets, it is a very time consuming process, because we have to generate all the item sets and we have to find out their frequency, and then we have to determine which are the frequent item sets. So in this case, the a priori downward closure property was proposed by the a priori. So what this a priori downward closure property says, because the such space, like suppose if there are 100 number or 15,000 items also will be there in a shopping mall, right, online e-commerce websites. So if that is the case, then the process of generating frequent item sets would be very difficult. So how we can avoid that? Like that is the such space. This is called as a number of frequent possible number of item sets. Item sets would be very high. So how we could reduce? Because here in the, if you observe this diagram, so these are only the frequent item sets. So these are not a frequent item sets. So these are not frequent item sets. Okay. So, but we have to generate all the item sets, and then we have to check their frequency. Then we'll come to generate the frequent item sets. But how to avoid? So because whatever the time we spend, whatever it could be in terms of a storage or a computational or a time, anything, so then that would be wasted. Whatever the time we spent, whatever that for these item sets would be wasted. So that's why it is time consuming. But if you take, like suppose 2 to the power of, like, so let us say 2000, then it would be a very big number. So in that case, there will be many number of infrequent item sets also, and also the such space would contain the huge number of item sets. So that would take a more amount of time. So how this such space would be reduced? So here, to reduce the such space, a property that has been introduced called as a priori downward closure property. Downward closure property. So what this downward closure property says, if an item set is not a frequent item set, if an item set is not a frequent item set, so no need to, then its a superset will never become a frequent item set. Okay, so that means when the item set length, the length of item set, increases, then the support or the frequency, so frequency would remains constant or decreases. Okay, that means the length of item set increases, the frequency of that item set would remains constant or decreases. It will never increase. So that is the property. Like suppose here, this is a one item set and these are the two item sets, three item sets and four item sets. That means the length of item set is increases. When the length of item set increases, the frequency of that particular item set will remain constant or decreases. Okay, so because of that, if an item set is not a frequent item set, then the remaining, that is superset of that item set. Superset means, like for example, let us take this D, item set D here. So this item set is a frequent item set. So then we'll check, but if any item, let us say BC is a infrequent item set because its frequency is 1. Now, if you could see the supersets of this BC, like what are the supersets of BC? From this you can see ABC is a superset of BC, BCD is a superset of BC. So no need to check the frequency of this, its supersets. That means the supersets of BC, those are ABC, BCD, right? So that similarly, if you could take the BD also, BD is also infrequent item set. So no need to check its supersets like ABD, BCD, etc. So that means we stop generating the supersets of the item set BD, right? Or if any item set is identified as an infrequent item set, then no need to verify its supersets, because when the length of item set increases, the frequency would remain constant or it decreases, right? So that is the way we could reduce the search space drastically. Like each phase, like let us say like first phase, the initial step, we could generate the one item sets, then we'll scan the database for their frequency, then we'll determine whether those item sets are frequent or not. Like suppose, for example, the first phase will find out the will I generate the item sets like A, B, C, D, that is, these are all one item sets, and we'll scan the database and find the frequency, then check whether they are frequent or not. So because all these item sets, single item sets frequency is 2, so it is the frequency is greater than or equal to the specified threshold, that is 2. So these are the frequent. So next step, we generate the supersets of these items. Okay, like AB, AC, AD, BC, that is at this level. Okay, so now because of this, why we have generated this? Because its subsets are frequent. So then we could generate the supersets. So we could generate the supersets, and again we find the 3 frequent item sets, but VC, BD and CD, these 3 are infrequent item sets. So next phase, and we will not generate the supersets of these items BC, BD and CD. So this is the way, step by step, we could reduce the item set. So the search space, entire search space would be drastically reduced. So then the complexity would be also minimized. So this is the way we generate the frequent item sets. So the remaining concepts we will discuss in the next lecture. Thank you for watching this video.